Hi everyone, I am Santhi from Department of Mathematics and Statistics, Bhavan Vivekananda College. I am here with my lesson 21 from linear algebra on vector spaces. In this lesson, I am going to explain these concepts: definition of rank of a matrix, rank theorem, and finding rank of a matrix. Let us define first what is rank of a matrix. The rank of a matrix A is the dimension of the column space of A. That is, rank A is equal to dimension column A. Let us look at some points about this. In earlier classes, we learned that dimension column A is equal to number of pivot columns in the echelon form of matrix A. That implies rank A also is equal to number of pivot columns in the echelon form of A. And the second point, dimension column A is equal to dimension row A, because we even learned about row spaces. After learning about row spaces, we mentioned that dimension column A is nothing but dimension row A, that is equal to number of non-zero rows in echelon form, because dimension row A is number of non-zero rows in echelon form. That implies rank A is equal to number of non-zero rows in echelon form. So we can take, though by definition we say that rank A is dimension column A, we can even consider that rank A is equal to number of pivot columns in echelon form of A as well as number of non-zero rows in echelon form of A. Now let us look at rank theorem. What does rank theorem state? The dimensions of column space and row space of an m by n matrix A are equal, and this common dimension is the rank of A, satisfying the equation rank A plus dimension of null space A is equal to n, where n is the number of columns. So in this rank theorem statement, this first line, dimensions of column space and row space are equal. Already we have looked about it while we were working out the problems, because dimension of column space, number of pivot columns and number of non-zero rows will be the same. That we will prove here in rank theorem. And since they both are equal, their common dimension it will be called as it will be equal to rank of A, and it satisfies the equation even rank A plus dimensional A is equal to n, which is equal to number of columns. Let us look at the proof of the theorem. So let A be an m by n matrix and B be its echelon form. So A, we have taken the matrix with m rows and n columns and we reduced it to its echelon form B. Then by definition, what do we have? The definition of rank A. Rank A is equal to dimension of column A. Let us take it as equation 1. Now let us look at what is dimension of column A. Dimension column A is equal to number of pivot columns in B. So let us suppose that it is equal to k. That is, there are k number of pivot columns in the echelon form B. That is equation 2. Now, each pivot column will give exactly one row with a pivot position. So if you have a pivot column, then correspondingly it will give you one row with a pivot position. What do you mean by that? Implies number of rows in B with pivot positions is equal to number of pivot columns in B. That is, in B, how many ever rows are there with pivot positions? There will be those many pivot columns. So we can say number of rows in B with pivot positions is equal to K, because number of pivot columns, we suppose it as K. That implies, now what do we mean by number of rows in B with pivot positions? It's nothing but number of non-zero rows only. Then that means dimension of row space is also equal to K. So from 1, 2 and 3 we have the equations dimension column A is equal to dimension row A, and which is equal to rank of A, because according to definition dimension column A is rank of A, that is equal to K. This is equation 4. We proved the first statement, first line of the theorem, that dimension of column A and dimension of row A are equal, and these two dimensions will be equal to rank, because rank is nothing but dimension column B. and that is we are assuming it as k. Now dimension null A is equal to, what is dimension of null A? We did in so all the problems, number of non-pivot columns in B. This we checked it even because all pivot columns will form dimension for column A, number of pivot columns. Then how many ever columns are remaining without pivot positions, that much will be the dimension of null A. This we were even observed while working out the problems. Then it is equal to, how many non-pivot columns will be there? Total number of columns in B minus number of pivot columns in B. What is the total number of columns in B is n, and the number of pivot columns is k. So it is equal to n minus k. So dimension null A will be n minus k, where k is the number of pivot columns. Now what do we have to prove? Rank A plus dimension A is equal to n. So here rank A plus dimension null A. What is dimension null A? Which is equal to k plus n minus k is equal to n. That is nothing but number of columns. Hence we proved rank theorem. Now let us look at this problem. Find rank A and hence verify rank theorem for the following matrix. Now by definition, what is rank A? So by definition we have rank A is equal to dimension of column space of A. This is one. And then what is rank theorem? And rank theorem is, what does the rank theorem state is rank A, rank of matrix A plus dimension of null A is equal to number of columns. This is rank theorem statement. So here, to find rank A, we need to find dimension column A, and after that to verify rank theorem, we have rank A plus dimensional A is equal to n, and also one more is also there in rank theorem, that dimension of row A is equal to dimension of column A. So we need to verify all these. So for this, what all we need to find? We have to find the dimension of column A, dimension of row A, dimension of null A, and then rank A. All these we have to find. So for all these, in previously when we were learning about row space, also we reduced the matrix to echelon form and hence find one by one row space, column space, null space, everything. The same thing we will do here. So first we will reduce this matrix to echelon form. So reducing A to echelon form, reducing matrix A to echelon form. So here I have in matrix A, we have, this is the first element which is a pivot element. So we will transform for row 2, we will apply R2 minus 2 R1, and for row 3 we will apply R3 minus 3 R1, and for row 4 also we will apply R4 minus 3 R1. So all these transformations let us apply, and then let us obtain. So let us write again matrix A is, what is the matrix A? Here we have 1, 3, 4, minus 1, 2, 2, 6, 6, 0, minus 3, 3, 9, 3, 6, minus 3, and 3, 9, 0, 9, 0. So after you apply these transformations, this is pivot position, and we are changing this by applying the transformations. So first row 1, 3, 4, minus 1, 2, and then this is pivot. We are using this, and then R2 minus 2 R1, 2 minus 2 0, 6 minus 6 0, and then 6 minus 8 is minus 2, and then 0, minus of minus 2 is plus 2, minus 3, minus 2 into 2 minus 4 is minus 7, and then for R3 minus 3R1 is 0, 9 minus 9 is 0, and then 3 minus 12 is minus 9, and then 6 minus of minus 3. So 6 minus, so it is 6 plus 3, which will be 9, and then minus 3 minus 6 will be minus 9. Then coming for the last row, R4 minus 3R1. 3 minus 3, 0, 9, this is also 0. 0 minus 12. So this is minus 12, 9 minus 1 into minus 3 is 3, 9 minus, so of minus 3 is 12, and then 0 minus 6 is equal to minus 6. Now this is pivot position is over. Next to pivot position we have here, and before that we can observe this, we can simplify this, we can simplify. So let us do the transformation for R3 divided by minus 9, and for R4 R4 divided by minus 6. So this matrix is transformed to now 1, 3, 4, minus 1, 2, and then 0, 0, minus 2, 2, minus 7, 0, 0, 1, minus 1, 1, and then 0, 0, 2, minus 2, 1. And then this is pivot. And now this minus 2 should be pivot, but before that it will be easy if I exchange these two rows. So let me exchange rows R2 to R3. So this matrix is transformed to 1, 3, 4, minus 1, 2. Now third row will come here, 0, 0, 1, minus 1, 1, 0. Then second row will go to third row, minus 2, 2, minus 7, 0, 0, 2, minus 2, 1. Now let us mark again pivot positions. This is pivot and this is pivot. Using these we have to do these zeros. So next we have to transform R3 and R4. So for R3 the transformation is R3 plus 2 R2, and then for R4 the transformation is R4 minus 2 R2. So the matrix will be 1, 3, 4, minus 1, 2, and then 0, 0, 1, minus 1, 1, 0, 0, and then minus 2 plus 2 R2 will be 0, and 2 minus of minus plus, okay, so it will be also 0, and then I have minus 7 plus 2 is minus 5, and then I have now R4 minus 2 R2. So this is 0, 0, 2 minus 2, 0, and then minus 2 plus 2 will be 0, and then 1 minus 2 will be minus 1. Now we have here this one and then this, and now we can see here these two. So let me just transform this R3 divided by minus 5. So this will be transformed to this matrix 1, 3, 4, minus 1, 2, and then 0, 0, 1, minus 1, 1, and then 0, 0, 0, 0, 1, 0, 0, 0, 0, minus 1. So this is pivot and this is pivot, and next pivot is this. So we have to do for R4 the transformation is R4 plus R3. So this matrix will be 1, 3, 4, minus 1, 2, 0, 0, 1, minus 1, 1, 0, 0, 0, 0, 1, and then 0, 0, 0, 0, 0. So I think it is completed about pivot, this one echelon form. So which are the pivot columns? C1, C3 and C5 are pivot columns. So let us write this information here. So C1 pivot columns, C1, C3, C5, and then basic variables. So what are basic variables in x1, x3, x5, and then free variables. The remaining are free variables x2, x4. Now we have to find out all row space, column space, null space, and everything we have to find out. So let me start with the null space. So first let me find about null A. So to find null A, what we have to do? We have to express basic variables in terms of free variables. So this we have to do it from the matrix. Whatever we have here, first equation is x1 plus 3x2. So row 1 implies, first row implies, right with the sum. First row implies I have x1 plus 3x2 plus 4x3 minus x4 plus 2x5 is equal to 0. This let me give it as equation 1. And then next the second row R2 implies I have R2 implies we have x3 minus x4 plus x5 is equal to 0. x3 minus x4 plus x5 is equal to 0. This is equation 2. And then R3 implies I have x5 is equal to 0. R3 implies x5 is equal to 0. This is 3. And here it is clearly this basic variable x5 is determined. It is 0. Now we have to get x1 and x3 basic variables in terms of x2 and x4. So substitute this 5 in from substitute 3 into. Then you have x3 minus x4 plus 0 is equal to 0, which implies you have x3 is equal to x4. So the basic variable x3 we have written in terms of free variable. Basic variable x3, this x3 we have written in terms of free variable. This is equation 4. Now let us consider equation 1. So I have x1 is equal to, so let us keep x1 this side because x1 is the basic variable, and then write all the other variables other side is equal to minus 3x2, x2 is a free variable, we have to keep it as it is, plus 4 into x3, not plus, it is, okay, let us write first minus 4x3 plus x4 minus 2x5 and then substitute minus 3x2 minus 4, x3 is x4 and then plus x4 is x4 minus 2 into 0, which implies we have x1 is equal to minus 3x2 minus 3x4. So this is another basic variable x1 we have written in terms of free variables x2 and x4. We have got all the free basic variables. Now let us write null A. Therefore, null space of A is equal to set containing how many variables you have, how many columns are there, those many variables x1, x2, x3, x4, x5. That is equal to, what is x1? Minus 3x2 minus 3x4. x2 is a free variable as it is. x3, what is x3 value? You got x3 as x4. So it is x4 and x4 is x4. And what is x5? 0. So this is equal to, so you have 5 variables, but they are reduced to 2 variables. What are the parameters? X2 and X4. So X2 into, so what is X2 coefficient? Minus 3, here 1 and here 0, 0, 0, plus then X4. What is X4 coefficient? Minus 3, and in the second row no X4, third row it is 1, fourth row 1, fifth row 0. So what do you mean by this? Which implies null space of A is span of these two vectors minus 3, 1, 0, 0, 0 and minus 3, 0, 1, 1, 0. Therefore, basis for null A is equal to, it is the same, minus 3, 1, 0, 0, 0 containing two vectors minus 3, 0, 1, 1, 0. Therefore, dimensional A is equal to 2. So we got dimension of null A. Next, let us write row A, row space of the matrix A. What is row A? Row A is equal to span of non-zero vectors from echelon form of A. So this is equal to span of, now let us go back and look at the echelon form of A. Where is the echelon form of A? This is the echelon form of A. So which rows you have? This is R1, which is a non-zero row. R2 is a non-zero row. R3 is a non-zero row, but R4 is not a non-zero row. It is a zero row. So first row 1, row 2, row 3. So now we will write, hence row A is a span of R1, R2, R3. These are from echelon form. From echelon form. That is equal to span of, what are the elements in the first row? Row 1, 1, 3, 4, minus 1, 2. And row 2 is equal to 0, 0, 1, minus 1, 1. And then third row is 0, 0, 0, 0, 1. So what is the basis for row A then? Basis for row A is nothing but I can simply say it has R1, R2, R3 from echelon form. And dimension row A is equal to number of vectors, which is equal to 3. So dimension row A is equal to 3. This is also completed. Now we have for us column A, column space of A. Now what is column A? According to definition, column A is a span of columns of A that correspond to pivot columns in echelon form. That is column space. So it is equal to span of, which are pivot columns in echelon form? In echelon form we have C1, C3, C5. C1, C3, C5, where these are taken from E. These are pivot columns in echelon form. So you should take here for column space. They have to be taken from A. So this is equal to, and it is equal to span of, so what is the first column given in the matrix A? That is 1, 2, 3, 3, and then next is C3, third column 4, 6, 3, 0, and fifth column 2, minus 3, minus 3 0. Therefore basis for column A is equal to set containing these vectors 1 2 3 3 and 4 6 3 0 2 minus 3 0, and hence dimension for column A is equal to 3. And now what is rank? Then rank of matrix A is equal to dimension of column A, and which is equal to 3 equal to 3. Also, what is the rank theorem? Also, we have here dimension column A is equal to dimension row A is equal to 3. They both are equal. Dimension column A and dimension row A, we got them both equal. We can check what is dimension row A, 3, and what is dimension column A, that is also 3. They both are equal. And what is rank theorem? Rank theorem, these both. Actually, rank theorem I can say this is also rank theorem only. And another one, what do we have to prove? Dimension of, not dimension, rank of A plus dimensional A is equal to, what is rank of A? 3 plus what is the dimension of null A we got here? Dimension of null A, we got it as 2. If you remember, dimension of null A is equal to 2. So let me write this. Plus is equal to 5, that is equal to number of columns in A. Hence, rank theorem is verified. Now let us consider an echelon form of a matrix. So this is given as an echelon form. So let me mark pivot positions here and then here, then here. From this one echelon form, we will draw all the inferences about dimension of column A, dimension of null A, dimension of row A, rank of A, all those we will infer only with this one echelon form. So suppose I have here pivot columns. C1 is a pivot column, C2 is a pivot column, C3 is a pivot column, and then C4, C5, not C2, sorry. Let us first write what are the pivot columns. C1 and then C3, C4 and then C7. These are pivot columns. So from this first I will write immediately number of pivot columns. I know how many are there. Number of pivot columns, that is equal to number of basic variables is equal to 4. 1 2 3 4. And the next inference that I draw from here is number of non-pivot columns, that is equal to number of free variables is equal to 3. So now let me write. From this, let me write some things like immediately I will first write dimension column A. So immediately number of pivot columns 4, then implies the rank of A, that is also equal to 4, which is equal to number of basic variables. These two are equal to number of basic variables, and then dimension of this is rank, dimension of null A. Suppose null A is equal to, what are remaining which are non-pivot columns? How many are there? 1, 2, 3. It is equal to 3, and you can even say this is number of free variables as well as number of non-pivot columns. All these are equal. And also you can say here, next one is, you can observe here, 4 plus 3 is equal to 7, that is number of columns in the matrix. And the next one, what can we write? The next one, next I will write dimension of row space A. Dimension of row A is nothing but number of non-zero rows. How many non-zero rows? 1, 2, 3, 4. 4 non-zero rows are there, and this is even equal to the dimension column A and dimension the rank of A also. So by just looking at one whatever the echelon form, we can write immediately all these inferences about dimension column A, rank A, dimensional A, dimension row A.